I'm going to pick up from where we left off on the notes from the other day. So you should already have this conclusion written down from the last video. And then I want to tell you that this conclusion up here, these three items in this conclusion, it's officially called the first derivative test. It's one of the most important tests that you're going to be using in calculus. So we'll probably just talk about a first derivative test casually, and you'll know what that means after we've used it in enough examples. So what do we use the first derivative test for? We use it to find local mins and maxes. Because if you can find where the f prime changes from plus to minus or minus to plus, then you can tell whether it's a local min or a local max. And you don't have to have a picture or a graph of the function that we're trying to find the local mins and maxes for. So we're just going to go through a couple of examples right now using the first derivative test. So here's your example. Let's find the relative extremas, or in other words, the local extremas. It's the same thing. For the function, let's say f of x is equal to 4, let me get this right. No, not 4. Let's say f of x is equal to x to the 4th minus 4x to the 3rd minus 8x squared plus 48x. So here's a fourth degree function. We have no idea what it looks like because we don't have a graphing calculator. We don't have a graph of it, but we're trying to find the relative mins and maxes of this fourth degree function. So our first step is to find f prime of x. So f prime of x, hopefully you can get this derivative in about 5 seconds. It is 4x cubed minus 12x squared minus 16x plus 48. Step 2 is to set it equal to 0. And we're going to solve this for x. So one thing that you can do is divide both sides by 4, because each one of these terms is divisible by 4, so that becomes x cubed minus 3x squared minus 4x plus 12. And this is a factorable polynomial. The factor by grouping would be taking out an x squared, you're left with an x minus 3. And taking out a negative 4 in the other two terms, you're left with x minus 3. So what you have is x squared minus 4 times x minus 3 is equal to 0. And then if you wanted to factor this out into x plus or minus 2, you could, but hopefully you know that the critical values are x is equal to plus and minus 2 and x is equal to 3. So there are 3 critical values in this particular problem. So now we have to see whether or not they're mins and maxes by setting up a first derivative test. With a sign table for f prime of x. All right, so what we're going to do is just set up a sign table with x equals negative 2, x equals positive 3, and x equals positive 2 on it. So here's negative 2, here's positive 2, and here's positive 3, and we're going to indicate this is the sign table for f prime of x. All right, so what we're going to do is we're going to pick a number that is less than negative 2 and plug it into f prime of x. So let's choose or x equals -3. So let's do f prime of -3 and see if it's negative or positive. And I'm going to cheat a little bit. I'm going to do -3 stow in x. And the derivative was 4x cubed minus 12x squared minus 16x plus 48. And that is a negative number. So we have a negative value. So this graph is coming down. And now I'm going to choose a number between -2 and +2. I think, oh, so that is a -120. So that's why this is negative. Now I'm going to do f prime of 0. Usually it's easy to put a 0 in here. And if you put a 0 into the derivative, you get 48, which is a positive number. Now we're going to do f prime of something between 2 and 3. I guess we'll use 2.5. It really doesn't matter. I'm going to cheat and use my calculator, 2.5. I'm going to store that in for x. And then I'm going to figure out that it's a negative value, -4.5. These numbers don't matter. It just matters that they are negative, positive, and negative here. And now I'm going to choose a number greater than 3. I guess I'll choose 4. And then we'll see what the derivative is, f prime of 4. And that looks like it's a positive number. So f prime of 4 is equal to 48, which is a positive number. So this sign table says that this graph is going to be coming down, that it's going to be going up, that it's going to be coming down, and then it's going to be going up because the sign table changes. The sign of f prime of x changes from negative to positive. So x equals -2 is a local min. X equals +2 is a local max. And then we're coming down, x equals 3 is a local min. So what we're going to do now is we're going to plug in x equals -2, +2, and 3 and actually give the points where they're local mins and maxes. So the mins are x equals -2, and I put this into my calculator here. And when x equals 2, y equals 48. And, oh, sorry, that was +2. When x equals -2, y equals -80. Sorry. -2, -80. AT. There's a min. So x equals 2. Oh, let's put the other local min. The other local min are x equals 3. And when you look at x equals 3, y would equal 45. And the max is when x equals 2, y looks like it is equal to 48. And now what we're going to do is just take a look at this graphically. I've got another example in here. And I think I need to change the window to be like -100 to +100. And so let's calculate this minimum point. Second calc min. And left bound, right bound, guess. So this local min is -2, -80, which matches with what we thought. Now let's do second calc max. That's the next one we come upon. Looks like the graph kind of comes up, and then it starts coming down a little bit. And this local max is x equals 2 and y equals 48, that maximum point, and that matches up with that. And now let's do a min, second calc min. So left bound, right bound. So x equals 3 and y equals 45. So we've got our local mins and maxes, and because this is a fourth degree, it rises to the left and rises to the right. So it would have no absolute maximum, but it would have an absolute minimum here. This local minimum down here is also the absolute minimum. So let's mark that, this absolute minimum. This is both the local and the absolute. This is just a local min, and this is just a local max, because the graph looks like this. All right, the last example I'm going to do for you is f of x is equal to 3 times x squared minus 4 raised to the 2/3 power. So let's find the relative extremas for that. So step 1, we have to find f prime of x. So 2/3 times 3 is 2 times x squared minus 4 to the negative 1/3, and then you have to multiply it by 2x as the chain rule. So f prime of x is actually equal to 4x all over the cubed root of x squared minus 4. So that's step 1, f prime of x. Step 2 says you're going to set this equal to 0, but the critical values are when both the numerator is equal to 0 and the denominator equals 0. So we're going to set for x equal to 0, and we're going to set the cubed root of x squared minus 4 equal to 0, because both of those are all the critical values. Remember, the numerator and the denominator both go to 0 for critical values. So if we set 4x equal to 0, we have one critical value of x is equal to 0. That's the numerator. And then in the denominator, if we cubed both sides, we get x squared minus 4 is equal to 0, cubing both sides to get rid of the cubed root. And then x is equal to plus or minus 2. So those are the critical values of this particular function. So now step 3 says we're going to set up a sign table. And a sign table has a -2 and a 0 and a +2 on it. And we're going to do, actually I always say that this is the sign table for f prime of x. And remember, f prime of x, not the original one, but f prime of x. We're going to see if these are negative or positive values. So if you plug in a -3 into this, 4 times -3 is a -12. I'm going to do this one by hand instead of using my calculator. If you plug in a -3 here, you get the cubed root of 5, which is positive, and a negative divided by a positive is a negative. You should be prepared to do things like this because I might not let you use a calculator. So negative over positive. Now we're going to choose a number between 0 and -2. So I would choose -1. So 4 times -1, that's a negative value, divided by 1 squared minus 4 is also negative, and the cubed root of a negative is a negative. So negative over negative would give you a positive. And now if you choose +1, you're going to get a +4 over negative. Positive over negative is negative. And then if you choose +3, you'll get 12, which is a positive number, over a positive number, which would give you a positive number. So there's our sign table completed. So this graph, it looks like it's going to be coming down, and that it's going to be going up, and then it's going to be coming down and going up. So in other words, the sign changes from negative to positive at x equals -2, which would give us a local min. And then it gives us a local max at x equals 0. And these are local mins and maxes. And then it comes down, and it looks like it's got another min at x equals +2. So now what we're going to be doing is plugging in x equals 0, -2, and +2 into the original function to find the y values so we can get the points that are the local mins and maxes. So f of -2, now going way back to the f of x function, that's 3 times 0 to the 2/3 power, which is 0. So negative 2 comma 0 is going to be a local min. F of 2 is also equal to 3 times 0 to the 2/3, which is 0. So positive 2, 0, those are both the mins. Now the max is when x is equal to 0, so f of 0 is equal to 3 times 0 minus 4 is negative 4 to the 2/3, which is equal to 3 times the cubed root of 4 squared, which is 16, which breaks down into 16 has got a perfect cube in it, it's 8 times 2. And the cubed root of 8 is 2, so we have 6 square root of 2. So that's the y value. So the maximum point is when x is equal to 0. Oh, that's the cubed root of 2, sorry. So 0, comma, the cubed root of 2 would be the local max. So we have 2 mins and 1 max. And let's just take a look at what this graph looks like, the original graph. I've already put it into my graphing calculator. So here's 3 times x squared minus 4 to the 2/3. I'm going to shrink my window down a little bit. Negative, I don't know, 5 to positive 5. Oh, maybe if I highlighted it, we'd see it. Oh, I better change my y max a little bit higher to 10. Oh, I know. On this max, I need to put a 6 on the outside of the cubed root of 2. That's my mistake here. So 6 cubed root of 2, that's why I didn't go up high enough. So this, the derivative doesn't exist here at negative 2 and positive 2, but still it's a local min. Second calc, I wonder if it'll calc the min on this if there's no derivative. Let's see what our calculator does here. Yep. So this is the number 0. Anything with a big e value here, big negative e value here is 0. So negative 2 comma 0 is a local max, local min. Here's the local max coming up. This number that we get for y should be 6 times the cubed root of 2. Let's see, 7.559. Let's see if that's 6 times the cubed root of 2. Yep, that's the same thing that we got before. And then because this is a symmetric graph, you can see where the local min over here would be 2 comma 0. So that's the first derivative test, setting up a site, well, taking the derivative, setting it equal to 0, finding the critical values, and then setting it up on a sign table. And if the derivative changes from negative to positive, it's a min. If it changes from positive to negative, it's a max. If it doesn't change, if it goes from minus to minus, then it's not any kind of min or max at all. And that's it for today.